Steam-powered, steam-powered, steam-powered. So you'd like to know about steampunk, would you, teens? Well, I suppose I can teach you a thing or two. If you're all about steam and brass, and all you need to depart is a team and a task, sharp set of gears and a gleaming arc, competitive robots seeking the start. If you're all about reaching far, seeking the game on secret charts, meeting in secret beneath the stars, loaded with pizza and feeling smart. If you're making a robot army, marching armed for starting a party, something so wondrous, and a specially constructed electrical bus so thunderous. Don't come to fuss, got a wanderlust and you're one of us. We bump steampunk, need one of these, job free, power free fun, here come the steampunk. Steam-powered, 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 steam-powered. Just bring your plans and plots and schemes. We've got the mechanics if you've got the dreams. All people, countries, cultures, teams. Welcome one and all to the age of steam. Keep it courteous, professional, worth it to work together in the first teamwork. The future of technology is all that it seems. Welcome one and all to the age of steam. Steam-powered, steam-powered, steam-powered. Steam-powered, steam-powered, steam-powered. We are looking forward in time, pushing past soot and factory grime. All other groups to the back of the line. We are the future, in fact, divine. Gleaming machinery is seen to be reckoned with. Every single member an excellent gentleman or lady, creating, leading a steamship in between T-ships. Because the people need this. You see, we're taking care of our crew like we do our facial hair. Be made aware when making improvements. Don't call it a scene, it's more of a movement, more of an era. Clearing the air, taking over, nearly there. Students, coaches, mentors, teams, welcome one and all to the age of steam. Hello, robot pilots. I'm Professor Elemental, noted adventurer, explorer, and rapper from jolly old England, and I love steampunk. For those of you who don't know, steampunk's a marvelous way of playing, inventing, and creating, all with a Victorian twist. That was my song Steam-Powered playing earlier. I'm delighted you can join me in this marvelously creative world of steampunk for your new game, First Steam Works. I've already had a look at it, and it's absolutely crackers. Now, I've got songs to write, and you have got robots to build. I'll check in with you later, but for now, it's back to Kickoff in America.
Thank you, Professor, and welcome to the 2017 First Robotics Competition Kickoff. I'm Katie, and I'm an alum from First Team 525, the Swart Dogs. As Professor Elemental said, we have a fantastic game for you. There was a lot of pressure to live up to First Stronghold, but we think we may have done it. We think you're gonna love First Steamworks, but we'll get to the game pretty soon. Right now, I'm standing in First Founder Dean Kamen's foyer, right next to this giant steam engine. Personally, I love the steampunk theme, and it was fun to watch the First community embrace it. Some of you teams got really carried away. There was even one team that... Whoa! Frank? Whoa, Don, where did you come from?
See, Don, we're back to the future.
This is definitely Dean's house. There isn't another one like it.
Back to the future? Where were you?
We just used Dean's steampunk computer to travel back to the Victorian era. I wanted to do a little more research on steampunk, and Don was up for a little time travel, so we went back to the age of steam, and it was great.
I felt like I was witnessing the birth of technology. The Industrial Revolution was in full swing. People were overflowing with ideas. Society was modernizing, and the amazing creativity. It reminded me of our teams.
Brass, copper, leather, so many gears, it was all so gorgeous. Real art in many ways. I felt like I fit right in.
You looked like you fit right in.
Well, I'm glad that you're both back to help me with the kickoff. How about a report on First Growth this year?
First Robotics Competition has added 20 events this year, and many new teams. Welcome, rookies.
And we're expanding internationally with new districts in Israel and Ontario, Canada, as well as a new regional event in Shenzhen, China. We're just taking off.
Wow, that's really impressive. A big thank you to all of our sponsors. Teams, when you get a chance, be sure to support and thank them. So Frank, about Dean's computer.
You should try it.
He's all right with just anyone using it?
Absolutely, as long as you're safe about it. In First, safety is always important. Whether you're on the ground or in the air, safety should always be a top priority for you. First is a lot of fun and a terrific challenge, but seriously, nothing you are doing is worth getting hurt over. Let me set a date for you.
Wait, what's that?
Uh-oh, it looks like Dean.
Hey Frank, what are you doing with my steampunk computer? Thanks to technology, I can tap into the user interface from anywhere, even up here at 40,000 feet flying my plane. It wasn't that long ago that steampunk was only science fiction. Jules Verne and H.G. Wells talked about incredible inventions like rockets to take people off the Earth, or communication systems for real time. Now we have the Internet of Things. It's always amazed me that a lot of kids will give you this knee-jerk reaction. I don't like science and math, but they all love Star Trek. They all love H.G. Wells, Jules Verne. Science fiction appeals to everybody. Well, the only difference between science fiction and science is timing. Look at where we are. We're flying an airplane at tens of thousands of feet in the air, going at almost the speed of sound, and maintaining full real-time communication with the world. This is unbelievable. But what's so unbelievable about it is that it's believable. It's real, and here's the proof. We want kids, through their first experience, to realize that whatever is in their imagination can become reality if they develop the tools, science, technology, engineering, and apply those things to the innovations to turn today's science fiction into tomorrow's science. And whether it's medical products, transportation, communication, energy, FIRST is about opening up all those possibilities for all of you. One of you will be sitting here in a few years in some machine that we will all be amazed by, that my parents have believed could exist, and you'll take it for granted because of your achievement. That's what this is all about. So my one piece of advice to everybody this year is don't be afraid to be a punk. Think outside the box. Create something you'll be proud of, that everybody else will think is cool. Try a lot, learn a lot, have fun. Sorry, gotta go. I'm on final approach, but I'll be there soon to pick up Woody with the helicopter.
Frank, if Dean's watching us, should we really be messaging?
Dean? Oh, hi, y'all.
Hey, Woody, welcome to Kickoff. What do you have there?
I've got some Victorian-era engineering tools.
Woody, check this out. Have you ever seen Dean's steampunk computer? It can take you back in time.
This is way cool. Set me up.
Woody, wait a second. Dean may be watching.
He won't care.
All I have to do is move this lever.
Wow, that was really exciting. I think all my molecules seem to have come with me. We appear to be in about 1870. That is a steampunk hot rod. This is a beautiful steam-powered water pumper for fighting fires. The designers, they didn't just make a hand wheel, they made a beautiful hand wheel. They didn't just design a gauge, they made something beautiful, a piece of art. If it survived the time travel, I brought a machine that could be used to evaluate the power output of a machine like this. If we connect the crank motion to this rotation and the pressure in the piston to this vertical axis, we get a plot that would allow us to get a rough estimate of the power output of a beautiful machine like this. Zoom back to 2017, your robot motor power. You can remotely and continuously monitor it with, in most cases, just a few lines of code. Clearly, technology changes are going to be important. If you just look at the vectors, the pointers, robotics, microbiology and genetics, artificial intelligence. And it's not just the technology that's changing, it's the process that's changing. Design thinking is now being taught not only in engineering schools, but in business schools. We understand the innovation and entrepreneurship processes better. Humans are understanding the universe more clearly, and humans are understanding ourselves and society more clearly. It's obvious that you have to learn more about the laws of the universe. Maybe not quite so obvious, you need to learn about yourself and other people. In your lifetime, the most successful people will be likely the ones who understand both. Now, when I was a hardworking assistant professor at MIT, the good news was that I was in a stress management class. The bad news was that I was in a stress management class because my assistant had signed me up. I sat there in the front row and this eloquent instructor told me about all my inner thoughts and insecurities. How could she possibly know that much about what was going on in my head? So I started to recognize that psychologists, cognitive scientists, social scientists have an important thing to say. For example, you need to study learning. You can get better at it. And you need to know what is known about thinking. Metacognition, not an obscure thing. Thinking about your own thinking is one of the ways that you can understand the difference between emotional and rational process. We thought IQ was fixed. It is, but rational thought can be learned. Epistemology. How do you know what you think you know? You're going to be awash in real and pseudo information. How do you know what truth is? So, if you learn everything you can about your robot, and you learn everything you can about the team and the process of making it, it'll serve you well. The FIRST is not perfect, but it's very good. The robot will obey the laws of the universe. So, if the robot works, it probably reflects your understanding of the universe. If your team competes well for the Chairman's Award, it probably means that you understand self and society quite well. These two major parts of what you do are a big deal. So learn that you can work with the laws of nature and that you can do things that artificial intelligence has not yet taken over. In your future, you'll always be needed because you have a uniquely human contribution. So use your FIRST experiences well. They will serve you well. Gracious professionals tend to be satisfied, happy people. Okay, it's time to get back to the future.
Pretty cool, huh?
Uh-oh.
Guys, stop playing around in there. It's time for the game reveal. Woody, I'm outside waiting for you. Come on, Woody, enough of this messing around. It's time to put the A in STEAM.
That's the stuff I've just been talking about, Dean. You mean art?
No, I mean airborne.
Oh, okay.
It's time to lift off. Good luck, teams.
Jolly good luck, all you robo-steampunkers. I can't wait to see your brilliant solutions. And stay tuned after the game animation for a live walkthrough from Manchester, New Hampshire. But for now, it's up, up and away. It's time to reveal the 2017 challenge. Welcome to the First Robotics Competition and the 2017 game, First Steamworks. 2 adventurer clubs, alliances of 3 teams each, prepare for a long-distance airship race by collecting fuel to build steam pressure, installing gears to engage rotors, and climbing aboard for liftoff. The airship best prepared for flight when the launch timer reaches 0 wins. Matches begin with robots touching their Alliance station wall. Teams may preload up to 10 fuel elements and 1 gear on each robot. Fuel is available in hoppers placed around the perimeter of the field. Additional fuel and gears are available at the Alliance loading station. During the first 15 seconds of the match, the robots are autonomous. They work to reach their baseline, score fuel in the boiler, or deliver gears to the airship. During the following 2-minute and 15-second teleoperated period, human drivers remotely control their robots. They continue to gather fuel from the field and the hoppers to score in the boilers. They also collect and deliver more gears. Human players located behind the Alliance station wall deliver gears and recycled fuel to robots through the loading stations. Steam pressure builds as fuel is added to the boilers. The high boiler produces more steam per unit of fuel than the low boiler. The more fuel scored in the boiler, the higher the steam pressure climbs. Alliances earn points for the amount of steam pressure built, and pressure over a certain level earns an additional bonus. Each airship has 4 rotors with some gears missing. Oh dear. gears delivered to the airship lifts are retrieved by the airship pilots, who then place them in the gear train to engage and spin up the rotors. Each rotor requires an increasing number of gears to become engaged. Points are awarded for each airship rotor turning by the end of the match. Airships spinning all 4 rotors also earn an additional bonus. Towards the end of each match, pilots deploy ropes for their robots to climb aboard. Alliances earn points for each robot secured aboard the airship by the end of the match. Be prepared. It takes time for the boilers to process fuel for the airships. Fuel put in the boiler near the very end of the match may not get processed before the airship takes off. The alliance with the highest score at the end of the match earns the win. Ready your robot, fly your banner, and prepare to take flight with this year's first robotics competition, First Steamworks! Ha ha!
Okay, just give me like a 5 count or something. Welcome! We are live on the first Steamworks playing field. How about that game, huh? I'm Blair Hundertmark, first lead MC. I've got my first steampunk facial hair started, and it's my job to be your host for the live segment. Now, you just saw the game. Pretty simple, right? Get some fuel, score it in the boilers, right? Get some gears, turn the rotors, climb the rope. Easy stuff. Maybe not so much. We want you to play this game, and you're going to have fun with it, right? Okay, you got a lot of questions. I know you have questions. You can put them right now, tweet them into us. #FirstSteamworks. We'll try to answer those questions towards the end of this before we reveal the manual code. So I've got a little help up here on the airship. Please welcome Director of First Steampunkery, Frank Merrick is
hey,
here.
Blair, how
Frank,
you doing?
Happy kickoff.
So excited. The team's upstairs. All our guests were just so excited about the game. I can't wait to see what the teams come up with, I'll tell you.
We're up on the airship now, and ironically, it might be the safest place. Like, we're now safest on the playing field and off of it.
We sure are. We got the team streaming in, and for the first time ever in a First Robotics Competition game, we are going to be having players right in the middle of the field, in the middle of all the action. The pressure that we have in the tank here isn't going to be the only pressure in the airship, because the 2 players that are here are going to have lots of work to do, I'll tell you.
Okay, so we'll have 2 pilots up aboard the airship, up to 2 pilots. Let's explore some of the other elements of the airship.
Sure.
So the rope is new. How does that work?
The rope, with 30 seconds left in the match, teams will release the rope like this. It goes down to the field. Robots climb up. They touch this pad. They bring this touchpad up. There you go. You have now successfully boarded the airship.
All right, great. That's the rope. What about the gears?
So the gears are delivered via this lift mechanism. Once the gear is delivered, team member pilot pulls this up, retrieves the gear like this, puts it in place, rotates, and then you get your rotor started that way. So lots for the pilots to do.
Okay, we've got 4 rotors on this ship, 2 pilots, lots of gears. I think we've explored the airship. Let's get on down. The team's getting a little antsy.
Okay, great. But now before we do that, teams, make sure, pilots, don't release this ladder yourself. You need to wait for a field reset person to come along and release that so you can get down safely. When you climb down, you're going to want to turn around and face the airship the same way that you come up. And that's it. Good luck, teams.
All right, thank you, Frank. Thanks for the tour of the airship. We're going to move on now to the hoppers and the boilers. Over here, it's Derek Foster, lead mechanical engineering. Well, he's our lead mechanical engineer. He actually built the field late into the morning. Welcome, Derek.
Thank you very much, Blair.
So it's kickoff day. Those aren't souvenirs. Don't take those. All right. I'm kidding. How much fuel is in each one of these hoppers?
There are 50 fuel in each container.
All right. And let's demonstrate how they get released.
So basically, robots just have to drive up. There's a polycarbonate panel, and they just need to push this lever, and it drops out onto the field.
Release the fuel. So maybe parking your robot under the hoppers is a good idea.
Absolutely.
All right, so now we've got the fuel. Where do we store it?
So this is the boiler. So basically there's a low goal, so robots can put balls into there. And there's also a high goal in the stack. Oop. And if you're a good shot, you'll miss again. And
He got it in
anyway,
rehearsal.
you gotta put it in the big stack.
You got it in rehearsal.
I hit it in rehearsal. Sorry about that.
All right, when you see Derek out on the road this year,
Make fun of me for that.
yeah, make fun of him. Give him a big shout out because this field is gorgeous and he put a lot of time and energy in it. Nice job of the field.
Thank you, Blair.
All right, while we are collecting your tweets, we are going to check in with our alumni and scholarship program. I'm going to duck under the airship and under the steam pipe. MCs, note this steam pipe. Flags this year are going to be an issue. With me is Michelle Long.
Hey, Blair.
Welcome. Happy kickoff.
Oh my gosh, this is amazing. Look at all these people here.
So your official title is Alumni Relationship Manager. What does that mean?
So that means that I get to work with everybody after they've completed their time on a first team. They become first alum. So that's things like the first scholarship program, internship portal, and alumni networking.
Cool. Now, what's new with the scholarship program?
So, really exciting new news about the first scholarship program. This year for 2017, there is more than $50 million being made available to first participants within the scholarship program from about 200 first scholarship providers. It's almost 2,000 individual scholarships.
That's almost doubled from last year.
It's amazing.
That's a great year for you. And so the scholarships, are they only for seniors or when should kids get involved?
Great question. So, while most people are going to apply for those scholarships during their senior year of high school, we want to make sure that all participants on first teams are aware of the first scholarship program, how it works, so that by the time they get into their senior year, it's easy sailing and they know what's going on.
So if you had 3 words for seniors and scholarships, what would they be? Or maybe one word 3 times?
You might have heard it before, but it's apply, apply, apply.
All right, great. Now, one thing I saw at some of the events last year, the regionals I went to, were these alumni patches.
Yeah.
What are those all about?
So starting last year and continuing this year, we want to recognize first alumni who stay involved with First. So you'll see at events throughout the year patches that First alumni are wearing that recognize that they're First alum, and those are available to volunteers at event days as well as mentors and coaches this year.
Great. Well, thanks. Thanks for all that you do.
Thank you.
Happy kickoff.
Happy kickoff. Have a great one.
Thanks. Thanks for the update. So the team is now kicking this field and inspecting it. They can't wait to get on this part of the field. We're also giving out kit of parts here at the Manchester, New Hampshire kickoff. And I have with me the kit of parts lead, the guru, Kate Pelot.
Good morning, Blair. Thanks
Good
for having
morning.
us. So I'm here with the rest of the Kit of Parts team. We got Jamie Luce and John Bryant. Now, JB, you took the lead on the kickoff kit this year. What are you most excited about in there?
Ironically, I'm probably most excited about the iron-on bumper logos that we have in the kit this year. I think it's just going to make everything look really good and kind of clean up the first branding.
Great, awesome, exciting. And now, so Jamie, you know that there's more to the kit of parts than only what's in the kickoff kits. Tell us about that.
Oh yeah, the product donation vouchers have been seriously increased this year. We have some really great new suppliers as well as some awesome software that's being included this year. You really got to check it out. And make sure you look at that voucher book that's in the kickoff kit because we tried to consolidate a lot of the vouchers together into one place so that teams have a lot easier time finding the information.
Yeah, I think that's going to be a huge help. Thanks for doing that. And then also, of course, there's First Choice, where starting today, you can add fuel and gears and rope to your round 2 priority lists.
So we are on the only assembled playing field in the world, and you can feel the buzz around the perimeter of the field. Everybody wants to get on this field. We're showing this to you live because some of these things you might not be able to build. So we know that you have lots of questions. We've been getting some tweets coming in, so we're going to go to Jamie now. Jamie, do you have a tweet there?
Yeah, we have a couple, and thanks for tweeting in this morning. It's so great to see everybody active on social media. We've had a great season so far. Let's keep it up. Keep that make it loud process on. But our first question is coming in from Team 5811, and they want to know, how do you earn ranking points other than win, loss, and tie? So that's a great question. Kate, do you want to answer that one?
Sure. So you can earn ranking points by building up a certain amount of fuel and by starting your rotors.
Great. And our next question is, JB's going to take this one. And this is from @WonderWeapon, and he would like to know how many balls can be held at any time.
So for this year, there's actually no ball limit on what a robot can hold. It's purely based on size constraints. So make sure you check out the robot rules because all the details are in there.
And another great question that we're going to answer. We're going to actually move over to the touchpad for this one.
Okay.
And the question comes from Fucino Hayden, and he'd like to know, how are the ropes deployed?
So the ropes are actually put up here, and we use this to lock them in. And then when you're up there and it's time to go, you just pull this, and the rope falls down like that.
And why don't we talk a little bit about that touchpad for a second while we're here? How is that going to work for robots at the end game?
So in the end, robots will climb up to the touchpad, and then they have to be triggering it, and it takes a second for it to light up. But once they get it for a second, at the end of the match, it will light up. If you stop, it will not light up, and it will not count. You have to be holding it for 1 second at the end of the match.
Awesome. Back to you, Blair.
All right, great. Australia, look closely at this field because it's being shipped to you in a couple of days. This is your field. It's the only one right now that's put together. We got to take it apart tonight and get it on a container to you. Thanks for the tweets. We know you'll have lots and lots of questions, and what we'll say over and over again is read the manual. Read the manual, read the manual. I think we're about ready to unveil the manual. We have a code, you know, it's encrypted until we release the manual. And I've got a special guest, a time traveler, coming back in to help. Oh, he's getting a little photo opportunity right now. It's time traveler Woody Flowers. Hi, welcome.
Fantastic.
Happy kickoff. What do you think of the game?
It's wonderful. It's really exciting.
It is. I feel like we're in a fish tank right now. We are like people just want to get in here.
I think we need to do this.
We need to do this. Let's unveil the code. If you give me a little help, right back here. And a 3, 2, 1. Full steam ahead. All right, we are ready for liftoff of the first Steamworks season. Have a safe build season. Happy brainstorming. Have great time at the competitions. Good luck, teams, and thanks for joining us at the kickoff here live in Manchester, New Hampshire. We're out.
Hi, I'm Jasmine, and this is Alex. We're going to take you on a tour of the airship. As we've said in blogs, manuals, etc., safety is crucial in the FIRST Robotics competition, especially this year when humans will be on the field during the match? What?
That's right. For the first time ever, drive team members will be allowed on the field during a match up in the airship. First up, pilots will need to climb aboard. Each airship has a ladder installed on the side facing the center of the field. The ladder will be down during field reset so that pilots can climb aboard. Before the match starts, a member of the field staff will fold the ladder up, securing the pilots until the match is over.
The pilots are protected from the robot action below by polycarbonate walls. There are portholes in the wall next to each lift for retrieving gears, but make sure you never reach outside the portholes. The portholes have another use too. In the case where fuel gets in your airship, we don't want you tripping on it, so use the portholes to clean it out of your way. Check the rules. This is the only way to get fuel out of your airship.
There are specific rules about what you can't touch while you're in the airship. The manual requires that you stay away from rotors, davits, and like Jasmine said, don't reach outside a porthole. Last note on safety. You're probably not surprised to hear that pilots will have to wear safety glasses while in the airship. We strongly encourage all pilots to secure their safety glasses with straps. Also, avoid loose-fitting clothes and tie long hair back.
One of the pilot's jobs is to receive gears. The only way to do this is with a lift. This video covers it from the pilot's perspective. Malcolm and Danny talk about it from a robot's perspective in the lift video. Once a gear is on a peg, a pilot operates the lift by pulling the cord to raise it up to the porthole. The pilot then tilts the carriage to bring the gear inside the airship where it's safe for the pilot to grab. When the pilot lets go of the cord, the peg falls back down to its lowest position. There's one exception where you don't have to use the lift to get a gear, the reserve gear. Once teleop starts, a pilot can grab the gear that's staged on the airship.
Once you have a gear, you'll want to install it. If you're using it for the center rotor, you just have to put it in the slot. A sensor will see it and start it up. To get the other rotors moving, you'll need different numbers of gears. They get installed on axles mounted vertically on the railing. The pilots just need to install each gear on an axle and line it up to make sure the gears mesh.
Once you've completed a gear train, you can start up that rotor. Do this by turning the crank for at least 3 revolutions. If the gears are meshed properly, a sensor will read that the gears are turning, and the FMS will start that rotor. Heads up though, the more gears in a gear train, the harder it is to get them turning.
Another job for the pilots is to deploy the ropes. This is done by opening the hook and loop strap. Finally, all this needs to be done while maneuvering around the steam tank. It's right in the middle of the ship and 2 feet wide, leaving pilots about 2 feet to work with. Lights show the amount of pressure in the steam tank. At 10 pascals, a row turns white. At 20 pascals, the row changes to the Alliance color. At the end of the match, the steam pipe lights will turn green. When the field reset crew lowers the ladder, the pilots can disembark. Up, up, and away!
I'm Malcolm, and this is Danny. Jasmine and Alex cover the lift from the pilot's perspective in the airship video. We're here to show you the lifts from a robot's perspective.
Each airship has 3 lifts. One lift is centered on each edge of the airship that faces towards the Alliance wall. I also want to point out the baseline, which runs just below the center lift. Make sure you read the game manual about getting those auto points. Given the geometry and various ways you could design your robot, placing a gear on the peg doesn't necessarily mean that you've technically reached the baseline. Pegs are relatively stiff springs with a barb on the end, which helps retain the gear. They extend about 11 inches out from the carriage. When the lift is at its lowest position, the top of the spring is about 13 inches from the floor. While the only way to get a gear to a pilot is by using the lift, there's no prescribed way to put a gear on the peg. Once the pilot determines the gear is safely on the peg, they can lift it up and away from the robot. Once they let go, though, the peg drops back down to the floor.
Drivers, use caution when interacting with the peg. It could impale your robot or get stuck in ways that could be debilitating. Or if dropped from the top by a pilot, could cause unanticipated damage. The final feature we want to show you are the barriers between the 2 lifts. There are 2 and they flank the center lift. These are mounted firmly to the ground. The barriers are about 2 feet long and 6 inches tall and shield the gear placing robots from getting hit from the side.
Hi, I'm Amanda, and this is Danny. Jasmine and Alex cover the ropes from the pilot's perspective in the airship. But we're here to show you the ropes from installation and robot perspectives. Each rope is suspended from a davit. They're equally spaced around the airship. One davit extends from the center of the railing closest and parallel to the Alliance wall. The other 2 are 120 degrees away.
If you choose to bring your own rope, make sure you read the game manual carefully about what you can and can't do. You'll want to make sure your retention knot is solid so the rope remains installed while your robot climbs it. Regardless of if you're using a field rope or your own rope, all ropes pass through the center of the touchpad and must be coiled and stowed before the match starts.
The field knows if a robot's ready for takeoff if it's triggered the touchpad. The piece of the touchpad which the robot interacts with is a horizontal polycarbonate plate that's 4 feet 10 inches off the floor. The plate must be pressed for at least 1 continuous second and while the match timer hits 0. It takes about 3 pounds of force to move the plate and has to be displaced by at least a ½ inch in order to trigger one of the sensors, with an additional 1 inch of travel.
The other important piece of the touchpad is the light because it communicates information. When there's 30 seconds left in the match, the light blinks. Also, if a robot's doing all the right things to actuate any of the sensors, the light will turn on and the associated points will be added to the Alliance's score. We need to be really clear though. Just because the light's on doesn't mean those points are guaranteed. If the robot were to let go of the plate before the end of the match, the light will turn off and the points will disappear from the Alliance's score.
Way to end our video, Danny Downer.
Hi, I'm Jasmine, and this is Derek. We're here to show you the boiler. It converts fuel to steam and then back into usable fuel. Don't ask, it's magical. Each alliance has a boiler at the end of their wall. Just in front of the boiler is the key. This area is marked with alliance color tape that is parallel to the face of the boiler. The tape is part of the key and the far edge is 4'4" from the face of the boiler.
Each boiler has a high goal and a low goal. The low goal is a rectangular opening in the front face of the boiler. It's 8 3/4 inches tall, 25 inches wide, and the bottom edge is 18 inches from the floor. The high goal is a round, horizontal, 21.5 inch diameter opening that's 9 feet from the floor and set back from the face of the boiler, 17 3/4 inches. The geometry of this can be approximated using 6 totes and a recycling container from 2015's game, Recycle Rush.
Recycle.
There's a vision target just below the high goal. It's made of 2 pieces of retroreflective tape that wrap around the tube. The top of the higher piece of tape runs along the seam where the stack meets the funnel. It's 4 inches thick. A 2-inch ring is 4 inches below it. The back of the boiler is surrounded by nets that extend about 10 feet above the floor. These nets are intended to keep missed shots in the field and not designed to behave consistently, so don't count on them as reliable backboards. You'll see that the manual specifies that fuel is scored as it's counted, not as it's put in the goal. For that reason, it's important to understand the rate at which the boiler can process the fuel. Our testing has shown a range of 4 to 5 fuel per second for each of the goals in the boiler, so 8 to 10 total fuel per second.
We also want to make sure you're aware that the goals have capacity limits. If you exceed capacity, the excess fuel will overflow out of the goal and onto the floor. Finally, any fuel that's not counted when the timer reaches 0 doesn't count for that period. So fuel that's put in a goal with 1 second left in auto, but not counted until 2 seconds later, will be counted as a teleop score. Additionally, fuel that's put in a goal with 1 second left in teleop, but not actually counted by the time the match ends, won't build additional pressure.
Full steam ahead.
Hi, I'm Amanda, and this is Malcolm. We're going to show you the loading station from the robot side. If you want to see it from the human player side, check out Jamie and JB's video, Loading Lanes. Your Alliance has 3 loading stations where you can collect game pieces from your human players. A single station is part of your Alliance wall, and a double station is part of your opponent's Alliance wall, located in the corner on the scoring table side.
Each loading zone has an opening through which game pieces fall. The opening is 7.5 inches tall, 2 feet wide, and the bottom edge is 2 feet 1 inch from the floor. The space in front of the loading station is the retrieval zone, because that's the zone where the robots retrieve the game pieces. It's marked by Alliance colored tape that is parallel to the face of the loading station. The tape is a part of the zone. The far edge is 3 feet 4 inches from the face of the station.
Hi, I'm JB, and this is Chuck. We're going to show you the hoppers. Each hopper is a pair of containers that sit just outside the guardrail. Hoppers are full of fuel, 100 fuel per hopper, split evenly between each container. Hoppers are staged around the field, 2 on the scoring table side and 3 on the opposite side.
To dump the fuel from the hopper, the robot pushes against this panel. It's 1 foot 10 inches wide by 1 foot 3 inches tall. As it's moved, it lowers the bottom of the container, and fuel is dumped from a height of about 2 feet. Containers are 2 feet 6 inches apart, so fuel dumps in 2 separate locations. Hi, I'm Chuck, and this is Matt. We're here to take you on a tour of the Alliance Station, including features that are unique to FIRST Steamworks. The most obvious difference is that the Alliance Station is smaller than in previous years. It is surrounded by the opponent's loading lane, so it's only 22 feet 4 inches wide by 8 foot 9 inches deep. You'll notice that there's a panel called a loading station between 2 of the player stations. If you're on the Red Alliance, it's between stations 1 and 2. If you're on the Blue Alliance, it's between stations 2 and 3. This is where your human player feeds fuel from your overflow bin back onto the field. You should watch out for any loose fuel on the floor. If this happens, we recommend you put it in your overflow bin or back onto the field via the loading station. JB and Jamie give more information about bins and how to use a loading station in their video, Loading Lanes.
The overflow bin is staged here, next to the boiler. If your opponent's bin overflows or isn't there, scored fuel ends up in your bin. It can be removed to transport fuel over to your loading station. Each player station has a shelf for an operator console. Note the strip of 2-inch wide hook and loop tape, loop side up. Each player station has an Ethernet cable which connects the operator console's computer to the field management system. The e-stop button on the shelf lets you disable your robot if necessary. There's an AC outlet for your operator console with a 2-amp fuse. If you find yourself in the middle player station, watch out for the equipment under the shelf.
Notice the stack lights above each player station. They relay information to the field crew for quick diagnostics. The bottom amber light indicates that your robot has been e-stopped. The top 2 lights match the Alliance color. If they are off, it's before the match and the robot is linked, but disabled because the match hasn't started yet. If the lights are flashing slowly before the match, once per second, it means that your robot has not yet linked to your driver's station. If your robot loses connectivity with the driver's station during the match, the lights will begin to flash again until connectivity is reestablished. If they are on, the robot is connected and enabled. You only see this state during a match. Each player station has a team sign that displays their team number throughout the match. The official time remaining in the match is displayed on signs hung from the top of each double loading station, which are identified with a white strip of tape. Don't forget to bring your banner to the field with you. Above your team sign is a holder for your standard. Make sure to place it securely so that it doesn't become dislodged during the match.
Above the wall, you'll notice the steam pipe. It starts at the boiler, runs across the top of the wall to the midpoint where it turns towards the airship. The steam pipe has lights that chase through it to indicate that steam is flowing from the boiler to the steam tank. 2 more things. The starting line is 2.5 feet away from the Alliance wall. Operators must stay behind it during auto. Visibility will be tricky this year, as large airships obscure parts of the field.
Hi, I'm JB, and this is Jamie. We're here to show you the loading lane. We'll start at the output of the boiler. When a robot puts fuel in the boiler, it's counted and ejected into the bins. Fuel fills this bin first. You'll want to pay attention to this because if your bin is full, the fuel is redirected into your opponent's bin. You can take the fuel from your bin or you can remove the bin completely. There are 2 other bins staged in your loading lane, so if you take the bin away, you'll want to put another bin into its place to keep the fuel from going to your opponent. The front of the bin holder marks the front of your loading lane. You're not allowed to touch anything outside of it. There are moving parts up there, so it's especially important that you stay back.
The bins are plastic, 33 inches long, 17.5 inches wide, and 13 inches deep. And they're pretty light, so even when they're full, they're manageable by most people. There's a double loading station on the opposite corner of the field from the boiler, and this is where you can feed fuel and gears to your robots. Fuel can be dumped or dropped into the chute at a height of 3 feet, 7 3/8 inches, and it will immediately roll out onto the field. The gears are staged here, in front of the starting line in the loading station. They get fed into the chute via this slot. To prevent a robot and human from being in contact with a game piece at the same time, something we fear could lead to injury, you can't be in contact with any inside surface of the chute or any part of a game piece that's inside the chute. So we strongly recommend that you play it safe and keep your hands out of the chute.
With all the motion included on the 2017 playing field, we asked our friend Jay Flores, Global STEM Ambassador at Rockwell Automation, to join us to talk about the components which make all this magic happen.
Let's start with the Alliance stations. Jay, what can you tell us?
Each Alliance station includes a Station Control Cabinet, or SCC, in Player Station 2. There's an armor block input-output module for controlling the LED pendant lights, and it tells us when an E-stop is pushed. The SCC has components to send power and data to the team number signs and acts as the Ethernet interface between the scoring table and the Alliance station.
More details on the software side of the SCC and how it operates with the rest of the field management system can be found in the FMS white paper.
Wow, so that's what the big white box does.
Now let's take a look at the boilers. Each one is controlled by a small enclosure we call the mini SCC. They contain 3 high-speed quadrature encoder-based counter modules, as well as 4 outputs, all of which are controlled over Ethernet. You may have seen these mini SCCs during First Stronghold. We use them to count the boulders scored in the towers. For First Steamworks, the mini SCC interfaces with a VisiSight sensor at the output of the boiler.
Hey, cool. Those sensors are in first choice, too.
Is he always like this?
Mostly. He gets really giddy when it comes to flashy lights. As I was saying, the mini SCC combined with the VisiSight sensor counts the fuel at the boiler output. That's it for the Alliance station. Let's go check out the Airship.
Each Airship has its own enclosure, which we tuck up underneath it. Power and Ethernet run to it through the steam pipes.
Each of these enclosures includes an Ethernet switch, some relays, and another armor block module.
We use the Airship enclosure combined with an infrared light sensor called RightSight to detect when the gears are spinning, operate the prop motors, and turn the auto lights on and off.
The final items that need some smarts here on the Airship are the touchpads. Each one has 3 sensors to detect when the plate has moved the required ½ inch. Some LEDs indicate when the climb is valid. We use the armor block I/O to monitor the state of the switches and to control the lights.
He's definitely going to be okay, right?